Good morning. We'll start a new chapter, Chemical Effects of Electric Current, session 1. So actually this is a very, what you can say is here there is so many things to study in this chapter, children, about chemical effect of electric current. But here in your standard 8th grade, we are only studying the brief part of this, which is chemical, while passing electric current, how the chemical changes take place. Now basically when we talk about current, electric current, they are nothing but flow of electrons. So our knowledge about electric current for standard 8 is only up to flow of electrons. How do that flow? Everything you study that in detail in 10th standard, where you have a chapter called electricity. You have a detailed study about the electricity part. Now, when electric current is passed in a given conductor or a given circuit, what I can tell here is, there are certain effects which takes place. Heating effect of electric current, magnetic effect of electric current, chemical effect of electric current. Now simple example, if I have to tell you, heating effect of electric current. We all have iron box at home which we use to iron our clothes, right? So how does that work? It just works automatically? No. We switch on the power, so electric current flows through it, through which heat is produced. We iron our clothes. Electric heater, electric toaster, how does that work? That works on the principle of heating effect of electric current, right? Similarly, in this chapter, we study a bit about magnetic effect of electric current as well. So that I will not give an example. We'll see in the chapter itself. That comes next, the chemical effect of electric current. So when electric current is passed, there are some chemical changes happening. Now, what are that chemical changes? How is it happening? We will study in brief about that in this lesson. So there are some terms what we have to understand before we actually start the lesson part. That is, electric current is nothing but flow of electrons. So actually what happens is, whichever direction the electric current flows, electrons always flow in the opposite direction. That is the convention of the electric current, right? But here nobody is asking you the direction. That's just a known fact what you have to know. As I have told you about electricity, about electric current, you will study in detail in 10th standard. So now generally if they ask what is electric current, it is flow of electrons. Electrons are negatively charged. That's enough to that knowledge if you know. Next thing here what you have to understand is about conductors and insulators. You all know what is conductors and insulators. I did not tell much about it. Substances which can conduct electricity. Materials which conduct electricity are called as conductors. Example, metals, right? Materials which do not conduct electricity are called as insulators. Rubber, wood, etc. Plastic. So these are all insulators. Basic things, you have already completed this in your 7th standard. The next is good and bad conductors of electricity. Now that means substances which conduct electricity are called as good conductors, I have told, right? We also have good conductors of heat and electricity both, but about heat we are not studying here. Good conductors of electricity, materials which allow electric current to flow through it. Suppose if I have this pen, if I pass electric current through this, of course if I pass it from here and I connect it to some other source, electric current cannot flow through this. That means electrons cannot flow through this because it is an insulator. So materials which allow electric current to pass through them are called as good conductors of electricity, and materials which do not allow electric current to flow through them are called as bad conductors of electricity. Examples, the same here. That's what the basic terms what you have to know here, which you have already studied in 7th standard G. Next, we move on to another one concept, another one term I can say, tester. So you all have testers at home, or if any time an electrician visits your home, have you seen him checking few things with his tester? Putting that tester into some sockets and checking the flow of electric current is there or not there, right? Not all the things which looks like a tester works as a tester. So basically what is a tester? It is a device to test a particular material whether it allows electric current to pass through it or not. So with the help of tester, you actually come to know whether there is a flow of electric current or not in that. There are many more activities given on all the concepts what I, for example, also on the tester part, there are some activities given. You can just read that, as well as some one or two activities I have also mentioned in the notes. You can just go through that. The next, conductivity in liquids. Do liquids conduct electricity? Yes. But do all liquids conduct electricity? Not all, but at least most of the liquids conduct electricity, I can tell. Now for example, let us just name it. What all things we know around us? Does water conduct electricity? Yes. But again, in water, if I talk about the water which is free from all the salts and minerals, which type of water is that? We use such water for our batteries. Distilled water. Distilled water is a type of a water which is free from all minerals and salt, right? Which is also not fit for drinking. Do you drink distilled water? No. It's actually hazardous to your health as well. So, water which is free from all salt and minerals do not conduct electricity. That means distilled water do not conduct electricity. Apart from that, normal water, of course, yes, your hard water, soft water, juice, anything, because that has many salts and minerals dissolved in that. So that conducts electricity. So conductivity in liquids, when we talk about, not all liquids, but liquids which are filled with or which are full of salt and other minerals, they conduct. In other terms, acids and bases also conduct electricity in liquid form. Now, acid, bases and salt you had studied in standard 7th, right? We have again in detail in standard 10th. But here, when I talk about liquids, acids and bases also conduct electricity in the liquid form. Suppose if I have, now sodium hydroxide is a base, right? Hydrochloric acid is a acid. Hydrochloric acid as well as sodium hydroxide, these both will conduct electricity only if it is in aqueous form. What is aqueous form? Liquid form. If it is in the dry state, of course, you also get sodium hydroxide powder. You also get dry HCl powder, right? Yes, you get that in your school lab or any of the chemical shops. You get them as per the requirement. We can procure that. So these what I can say, acids and base, only if it is in the liquid form, water form, aqueous form, they conduct electricity. Otherwise, in the dry state, suppose if you have a dry HCl and you pass electricity through it, there will be no flow of electrons in it. But if I just put some drops of water and make it aqueous, right, then it conducts electricity. So liquids as well conduct, most of the liquids. But distilled water do not conduct electricity because it is free from all minerals and salt. Then, in most of this conduction experiment when we do, we always use LED bulbs. You all know what is an LED bulb, right? Have you seen? What is it? So it is actually called as light emitting diode. LED bulbs are found in your remote, TV remotes, in the play toys, where a small bulb will glow. But in basic experiments when we are conducting, why is the LED required? LED bulbs are the most suitable for testing electrical conductivity. Why can't we use our normal bulb, right? A 0 volt bulb, so many different types of bulbs we have. Why we do not use them? Because now what happens in the bulb, the capacity or the bulb capacity is how whenever the electric current flows through the bulb, what happens is the filament glows. You all know what is a filament, right? So this is an electric bulb, children. So there is, nowadays in LED bulbs you don't see the filament actually. I am talking about the bulb with the filament. So what happens? This filament starts heating. That with the heating effect it starts glowing. You study this in detail in standard 10th here now. But for this bulb to glow, filament has to get heated up to a certain temperature. Only then the bulb will glow. That means it requires a very high power. Suppose if I have 30-40 watt bulb with me and if I just use a 5 volt battery, will 5 volt battery enough to glow this bulb? No, filament will not get heat only. If the filament does not get heated up, how will the bulb glow? Right? But LED, what is it? Light emitting diode. A very small negligible current is also enough for a LED to glow. Right? It does not require any heating effect. It just requires a minute flow of current. So even a 5-volt battery, forget about a 5-volt battery. You have a pentorch cell which we use for our calculators or a wall clock, right? So that pentorch cell also is enough for a LED to glow. You can try this out at home if you have an LED, but do not play with any electric circuits. So as teacher has told to give a try, so never play with any electric circuits. So that is why LEDs are the most suitable for testing electrical conductivity, because it can also glow with a very minimal flow of electric current, or with a very small electric current also LEDs will glow. So for the most of the experiments when we conduct, we always use LEDs. Next, electrolyte. What is an electrolyte? Conducting liquids are also called as electrolyte. Now I will explain this about electrolyte in detail when we study the concept of electrolysis. That's the next part of it, right? So I've just written here as the part as the lesson goes. But electrolyte is a conducting liquid. Whatever liquid we have, that is called as an electrolyte. How? Why? We will understand this much better while learning electrolysis. I'll go on to the next one. Magnetic effect of electric current. Now, heating effect, still I have not come to chemical effect yet, right? So, heating effect we don't study here. So, magnetic effect of electric current, when I talk about is what it could be. That is, when I pass electric current, it will get magnetized. Now, a simple example if I have to give you children here is, have you all seen a compass needle that will show north and south deflection, right? So, suppose if you have put your mobile for charging wire is there. If you take the magnetic compass near the charging wire, there is a small deflection in the magnetic needle kept aside. Suppose if you have a magnetic compass and you have a bar magnet in your hand. So, this is a magnetic compass here which will show north and south direction. Now, if you have not seen the magnetic compass, I am not carrying any magnetic compass with me. Type in Google magnetic compass. You get to see a magnetic compass from the bigger one to a smaller one also. Or tomorrow if your school starts, in case you get to see in your school laboratory, you will definitely get to see this. And I have a bar magnet which is kept here, right? So, there is no deflection found in this. But I bring this bar magnet close to the magnetic compass. Magnetic compass start deflecting because due to the presence of magnetic field, right? There is a magnetic field here. That is why there is a magnet here. If there is a magnet, there is a magnetic field. That is why the compass started deflecting, right? This is with the natural magnet what you have. But suppose if you have a wire, that's what you put it for a charging. You have a wire. Now, when you bring that magnetic compass near the wire, there is a small deflection seen in the wire. But you have not brought any magnet towards it. How is the deflection? There is a deflection because, now what is there inside? There is a copper wire inside, right? So, when the current flows through that wire will behave like a magnet. What type of a magnet? Temporary magnet. What type of magnet is this? Permanent magnet, right? You can't change anything. But if I switch off the power, there is no deflection. So, that temporary magnet power has gone. If I again switch it on, that copper wire or that conducting wire will behave like a magnet for some time until there is a electric current flow through it. So, that is called as a temporary magnet. Why it is behaving like a magnet? Because when electric current passes through it, it creates a magnetic field around it and the compass needle starts deflecting. This is called as magnetic effect of electric current, which behaves like a magnet due to the passage of the electric current. Yes? You have experiments, Oyster experiment and several experiments on this because you have again separate chapter in 10th standard children magnetic effect of electric current. Here it's just one small concept what we are studying. So did you understand the process of magnetic effect of electric current? Now here in your book what they have given here is, they have given a magnetic compass, okay, a battery is given and a potato is given. So both the terminals here are inserted in the potato. Now there is a magnetic field created, or once the current is passed through it, how do you come to know? Because here near the positive electrode, how do you know it is a positive electrode? You come to know because there is a bluish green spot which is created. These are all general, you don't have an actual experiment here. All activities what you have to check with respect to magnetic effect of electric current, right? So this is one activity where they have shown how electric current is generated, which magnetized due to the effect of magnetic effect of electric current. So here in the potato there is a bluish green spot, so which indicates the presence. So this is about magnetic effect of electric current. So I have just given 5 volt battery, 6 volt battery, depends. A small source is given. They have not mentioned how much source is that. This is the source, this is the battery. These are all symbols you will learn later, children. This is a positive. The longer one is positive, the shorter stick is negative. These are all activities which are just given in your book where you just see them. Suppose if you have school tomorrow, they might perform this in your school laboratory. Now, the next important concept we will start about electrolysis. So that's what I have told about an electrolyte. Let us understand in the process of electrolysis, where the application is called as electroplating. That is one most important concept in this lesson we will study now. So before we proceed with the next one, so in the previous part what we understood was a very basic thing about magnetic effect of electric current, right? So how the things get magnetized when electric current flows through. That was only one experiment, not as an experiment, as an activity. You can read that as well in the book. The second concept which I told you was of a potato. I will explain that once we understand the chemical effect of electric current. So first let us understand the actual meaning of chemical effect of electric current, and there are several such activities based on chemical effect of electric current, which one example is of the potato, which we have just understood about that. We'll understand that in detail. But to understand that, there are few other more terms of chemical effect of electric current. Let's first understand that, children. Now what is chemical effect of electric current? Definition wise, when electric current is passed through a conducting liquid. Now what type of a liquid it is? If it is a conducting liquid, that is called as a electrolyte. What is electrolyte? We have this in the definition. When an electric current is passed through a conducting liquid, then chemical changes takes place. This is called chemical effect of electric current. So applications of chemical effect of electric current you actually study in your higher classes, that is how a water decomposes itself like with the chemical effect of electric current to hydrogen and oxygen through a process of electrolysis. That is some chemical changes which happen which decomposes the water. Now what does water consist of? Basically you don't study much. 2 molecules of hydrogen and one oxygen. So here during this process, when electricity is passed through a liquid, that is water, it decomposes itself to hydrogen and oxygen. You study this as an experiment, a very important concept in standard 10. Something which is called as chemical effect of electric current. Now the process is called as electrolysis. Let's understand few more terms here. What is an electrolyte? That conducting liquid is called as a electrolyte. A liquid which conducts electricity. It is a solution that breaks into ions on passing electricity through it. A solution that breaks into ions. 2 different parts it breaks. Ions are what? Positively charged, negatively charged. Those are called as ions. What are electrodes? An electrode is a conductor of electricity that carry electric current. So we dip these electrodes into a electrolytic solution, you can tell. Now anode, what two types of electrodes we have. One is anode electrode, which is called as an anode, and another one is a cathode. Now positively charged electrode is called as a anode. Negatively charged electrode is called as a cathode. So when I talk about, I use electrodes in the experiment of electrolysis or in the electrolytic solution. I insert two electrodes. It's always an anode and a cathode. That is a positively charged electrode and a negatively charged electrode. See, the name you have to remember very clearly. Anode positive, cathode negative, electrodes. Then comes ions. Now we discussed here, it decomposes itself into ions, right? What are ions? Ions are positively charged, negatively charged. We call them as anions and cations. See, they are reversely opposite. Anions are negatively charged ions. They are minus. Cations are positively charged ions. So, if you remember anode and cathode, remembering anion and cation is the complete reverse of it, right? Don't get confused in this. Anode and cathode are the electrodes. Anions and cations are the charges, ions, what we talk about. Last is the electrolysis. The chemical decomposition produced by passing an electric current through an electrolyte is called electrolysis. The components of the compound get split. That is what? Due to some chemical effect, what will happen? The components get split. Now that is how water is decomposed into hydrogen and oxygen. So a part where hydrogen gets collected and in the another part oxygen gets collected. We study that in detail in standard 10. Now based on this chemical effect of electric current, let us understand few activities in which that potato activity is 1. So now, one of the very main important concept of this chapter is electrolysis process. Now, as I have told you, we will see some activities of this chemical effect of electric current. The one activity here is nothing but electrolysis process. Here it's a very basic thing what we are studying here, children. In detail, as I have told you, in 10th you have that. So what happens here is, we have taken two electrodes dipped in the water, right? Now these two electrodes are nothing but carbon rods. Carbon rods are electrodes. Do you know that pencil what we use, graphite, those also acts as electrodes, okay? So two carbon rods are taken. So this is cathode and this is anode. I mean connected to the respective terminals. Now what we do here is we just add few drops of lemon. Lemon what? I mean just few drops of lemon, what you can say lemon juice to it, so that it can add slight acidic to it, so that conductivity is more. Once electric current is passed through this solution, this is an electrolyte now. So once electric current is passed through it, what will happen is, you can see some bubbles kind of thing depositing or just moving from the electrodes. That is nothing but water gets disassociated or water gets decomposed, splits into hydrogen and oxygen, and those gases are separately collected in the different test tubes. So here we have to only understand this much about electrolysis process. Now the another activity what has been given in the book is about when connect a battery, a source, to a magnetic compass, this to show the deflection of the presence of electric current where the magnetic field is created. When the deflection, immediately when you pass the electric current, what happens? That creates a magnetic field showing a slight deflection in the compass. So it is connected to two nails, one into positive to positive here, two iron nails. Those are just pierced into the potato here. Now what will happen as soon as you pass electric current? Near the positive terminal, something bluish or greenish color kind of things get deposited, or you can see a patch of bluish green color. But wherein in the negative terminal, there is no such color change effect. So what is this happening? Chemical change or chemical effect of electric current is shown here with the presence of change in color. Chemical effect of electric current is shown here with the presence of decomposition of water to hydrogen and oxygen. Now where is this actually chemical effect of electric current used in application, or where do we use it? Only electrolysis or just in checking other form? No. We use that in electroplating. You all know what is electroplating. Now, a simple example if I have to talk about is, sometimes we wear ornaments. Of course, they are gold ornaments, silver ornaments. Have you heard the thing like 1 gram gold, or it is a silver, or it is an ornament which is coated with silver, the upper layer is silver coating, something like that? What is it? Something called as a electroplating, where you coat a metal over another metal, right? But which metal is coated, that you have to know. Actually, we need not do that, but the one goldsmith or any industry or anybody who will do this process will actually do. Let's understand the definition wise. Electroplating is a process of coating a metal using electric current and electrolyte. So here electric current is required as well as an electrolyte is required here, because that is a conducting solution. Using this electroplating is done in bigger industries, factories, etc., where these manufacturing things are done. A very important question, what is electroplating? Applications, where do we use in our day-to-day life, along with the experiment they ask you. Simple process, we take two electrodes, we take two copper plates here, okay. Whichever metal plates you take, the same metal salt is taken. We take a salt of copper sulfate. Copper sulfate is a salt, okay. Naturally, when we talk about salt, to your knowledge, only sodium chloride, common salt what we use is the salt, right? Apart from that, all the chlorides and sulfates are the salt. So we use a salt which is an electrolyte, copper sulfate, because you want to separate copper. From this copper sulfate, you want the pure copper to be obtained. A plating is done. So this is a simple process, children, here, but we can't be doing it exactly how they have made. There are some particular units which they carry on this. So we connect the copper plates, connected one to positive terminal and one to the negative terminal. Now what happens here, in this copper sulfate solution, we also add few drops of sulfuric acid. Why sulfuric acid? To make the liquid more conducting, right? When electricity is passed through it, we want a strong conducting liquid there. Once electric current is passed, copper sulfate solution is a combination of what? Copper and sulfate. So copper and sulfate gets disassociated, decomposed, I can tell here is, it gets separated. So the free copper which is available, that gets deposited on the negative terminal of this copper plate. All the free copper from the copper sulfate which will get separated, that gets accumulated on the negative terminal. Now what will happen here? From the positive terminal, whatever copper is there, that gets dissolved in this solution, copper sulfate solution. So the process goes on. From the positive terminal, copper gets removed from that and gets dissolved in that, get mixed with that copper sulfate solution. Copper sulfate solution will again get separated. Free copper is deposited on the copper plate. This process continues till we get the accumulated amount of copper, free copper on this, right? This is how the copper is obtained, or you can say this is how the electroplating is done, which we coat it of a particular metal onto the another metal. Now, where do we use this application? It's been widely given in your book, children. Applications of chemical effects of electric current, one is electroplating. Electroplating definition I have mentioned here. Different metals used for electroplating are nickel, copper, gold, silver, tin, brass, zinc, chromium, platinum. These many metals are used. It is used in many industries for depositing a layer of metal with desired characteristics on another metal. See, basically we only know one thing. What is it? 1 gram gold, what we say, or silver coating, what we say, right? It's nothing but an electroplating only. Medical equipment is made up of nickel, which is harmful to human body. Hence, avoid it from coming in contact with our body. A coating of platinum or gold is applied on the surface of the nickel. So all the equipments probably they are made up of nickel, but the coating is of what? It's either of gold or platinum because it should not get in contact with the human body, which might be dangerous. Done via electroplating. Many kitchen equipments, bath taps, parts of car are covered with chromium coating. So chromium is an expensive metal, hence objects are created with a cheaper metal and chromium coating is provided on that. Okay, completely we can't buy it of a chromium, right? So only the chromium coating is used, the other is made up of another metal. So jewelry makers often make ornaments of less expensive metal and provide a coating of gold or silver upon them, which we generally call it as a 1 gram gold, right? It's not exactly a 1 gram gold, but the name gives that. It might be a gram of a gold or a little amount of gold is used just to coat it and give that glossy or the shiny finishing on the gold. So tin cans that are used to store food are actually made up of iron and have coating of tin on them. So iron can easily react with food and spoil, right? It rusts easily because of moisture and water content. So we have a tin coating on that. So however, tin prevents the food from getting reacted with iron and therefore helps in preventing it from getting it spoiled easily. Bridges and various parts of automobiles are made up of iron because it provides strength. However, but it's made up of iron, but it has to get protected from the rust, right? So they give a zinc coating on that. So this is how electroplating is used in wide different sectors. Medical, we know where it is used. So in household, where it is used. In our daily requirements, where it is used. So different fields we make use of electroplating just to make the life and simple. And since certain things are so very expensive, so a small coating over them can be afforded by everybody. The last concept in this lesson is about different effects of electric current, which we already discussed in the beginning. That is, one is heating effect, mechanical effect, magnetic effect and chemical effect. I can still say that about chemical effect of electric current, we have just studied just one part of it. So in detail you will again have that in your higher classes. About heating effect and magnetic effect, you will study that in your 10th standard as well as a detailed study of electricity about electrons in standard 10th. So with this we complete this chapter, chemical effect of electricity.